The melting point of a substance is a characteristic property that could be used for identification. Comparing the melting point of a pure substance to that of a mixture can also be used to qualitatively assess purity. At the molecular level, a pure crystal of a compound is composed of a regularly repeating pattern. Since all the molecules in the pattern are identical, they hold their shape well and require a certain amount of energy or heat to pull them apart and melt into a liquid. If an impurity is present, the regular pattern is interrupted and the individual molecules are not held together as strongly. This mixture will have a lower melting point than the pure substance, since less energy is required to overcome the relatively weaker intermolecular interactions. It is important to note that melting points are recorded as ranges rather than singular temperatures. Also, purer substances will melt over tighter ranges than impure substances. A melting point apparatus is used to measure melting point ranges of solids in the laboratory. Before beginning, make sure the thermometer is functioning and that the temperature of the heating block is below that of the expected melting point range. Your solid should be a fine powder. If it is not, use a glass rod or a mortar and pestle to grind it into a fine powder. Take a melting point tube and dip the open end into the solid. Don't confuse the melting point tubes with TLC capillaries. Melting point tubes are enclosed on one end. You should fill 3 to 4 millimeters of the tube with solid. Hold a larger hollow glass tube on the lab bench and drop the melting point tube closed side down. The solid should be tamped down to the closed end. Repeat if necessary. Place the closed end into the top of the apparatus. Up to 3 tubes can be inserted at the same time. Turn the light on and look through the viewport to confirm that you could observe the sample. Turn the dial on to begin heating. The higher the setting, the faster the heating will occur. If you don't know the melting point range of your substance, the most efficient approach is to do 2 runs. In the first run, apply fast heating starting at room temperature to determine an approximation of the melting point range. Then cool the apparatus down to a temperature just below the melting point range, and then apply slower heating in the second run in order to get a more accurate representation of the melting point range. If you know your melting point range, then the most efficient way to determining the melting point of your sample is to run the temperature up quickly to just below your known range, and then slow the rate of heating down so that you get an accurate melting point range. Record the temperature when your first drop of liquid appears in your sample, and then record the temperature when the entire sample is liquid. These 2 temperatures compose the melting range of your sample. Don't forget to dispose of the melting point tubes into a broken glass box. In some cases, you may observe decomposition rather than melting. In these situations, you should record the range over which the decomposition occurs. Combined with other analytical tools, melting points are useful for characterizing solid compounds.